Have you ever thought of using a spark plug as a diagnostic aid? Did you know the presence of certain foreign materials on the plug electrode can be used to localise or pinpoint electrical or mechanical faults within the engine? If the spark plugs need to be removed from the cylinder head for diagnostic purposes, or just part of a routine service, there are some best practice operations that need to be performed first. Use some compressed air and a rag to clean around the plug and cylinder head. It's very important that no foreign objects drop into the combustion chamber during removal or service. Remember, some manufacturers recommend a cooling period before the plugs may be removed. Always use the correct size plug socket fitted with protective insert. This will minimise the risk of breaking a plug insulator. Remove each plug and place in order. We need to identify each spark plug with its corresponding cylinder. There are a number of areas that need to be closely inspected to aid in diagnosis. We need to confirm the plug tip is secure with no visible damage or burning. Some terminals have a threaded cap, although most are fixed. Look very closely at the insulator for surface cracks, a loose fitment to the shell, and especially for any track marks that may indicate a subsurface crack or poor high-tension lead insulation. Examine the hex nut that is formed as part of the shell. It must be free from damage or rounded edges. Inspect the crush washer or taper for correct fitment. Carbon deposits or burning in this area may indicate a leaking combustion seal. Inspect the thread for any damage. This may be a result of poor fitment from a previous repair or wrong reach plug previously installed resulting in contamination. Study the ground and earth electrodes closely. Any bending may have been caused by incorrect gapping or installation damage. It may also be due to an incorrect reach spark plug fitted, or even a foreign object in the combustion chamber. An incorrect heat range plug, lean mixtures, or an engine suffering from pre-ignition will cause the electrode edges to round off, or show signs of accelerated wear. Let's take a look at some spark plugs we removed from engines with a variety of faults. This plug is fuel fouled. As you can see, it is dry but carbon coated. This may have been caused by an excessively rich fuel mixture on that cylinder, low compression, or contaminated fuel. There is still a partial burn taking place. A spark plug that looks very similar but appears wet indicates that no burn is occurring in that cylinder. An ignition system fault may be the cause. This spark plug displays evidence of oil burning in the engine. The oil turns to carbon during the combustion process. The carbon builds up around the electrode and insulator. This may be caused by low compression, leaking valve guides or seals, or even turbocharger failure. Coolant contamination is evidenced by reddish or green staining of the electrodes. The coolant may be entering from a crack in the water jacket or past a decayed gasket. A spark plug with an extremely white finish or blistering on the electrodes indicates a very lean mixture within the combustion chamber. Causes could be attributed to intake manifold leaks, fuel starvation issues, or incorrect valve timing. This is a correctly operating spark plug. The electrodes have a light caramel coating, proving an efficient air-fuel mixture with adequate compression, correct timing advance, and a correctly operating ignition system. This mark on the insulator is known as a corona stain. It is caused by suspended oil particles in the surrounding air adhering to the ceramic, due to the high voltage within the ignition system. This stain does not affect the operation of the plug. It's imperative a spark plug's gap is checked and adjusted correctly. Failure to do this will result in a possible misfire, low power, poor performance, and increased fuel economy. Most spark plugs used in modern passenger vehicles come preset at the correct gap, but an experienced technician knows anything could happen to the plug between manufacture and assembly to the time it is removed from the box and fitted to the vehicle. The spark plug air gap provides the optimum spark to be generated by the vehicle's ignition system. As plugs wear, this gap may increase, or a foreign object may impede the plug's ability to close the gap. The edges of the electrodes must be sharp and parallel, as this allows for a clean spark to jump the gap. Should this gap become distorted, the spark will become less effective. Resetting a gap is a simple process if the correct tools are used. Specialty plug gauges are recommended for this task, as when used correctly, they give an accurate reading. Many of these special tools have slots designed for bending the earth electrode. No spark plug can operate effectively without efficient delivery of the spark. This is the job of the high tension lead. Early leads were primarily single core copper wire, approximately 2 to 3 millimetres in diameter. They were insulated with a heavy rubber-based material and had terminals attached at either end. Over their service life, they could be adversely affected by heat, cold, contamination from oils and fluids, and engine vibrations. This type of lead had no means to suppress or reduce electrical interference, and as such, affected radio transmissions and in later years, the operation of onboard management systems. Radio frequency interference is reduced by limiting the current flow in the wire. However, this reduction in current flow also results in a weaker spark to the plugs. Modern vehicle electronics and RF transmission laws have dictated the need to overcome the drawbacks of traditional wire leads. This has introduced us to the carbon resistor ignition cable. These are constructed with a carbon impregnated glass fibre core surrounded by a high density insulator. The carbon provides a strong, consistent spark while adding the value of suppression resistance, which helps to eliminate radio frequency interference. Using a resistive wire to reduce the current flow and therefore lower RFI is counterproductive to the ignition system's main purpose. A new type of high tension cable has been introduced to overcome the shortcomings of impregnated core leads, while retaining the benefits of solid copper core cables. These leads work exceptionally well with different fuel types, maintain the required suppression characteristics, and have a very low internal resistance. These leads use reactive energy to reduce RFI. They are designed with a coiled stainless steel or nickel copper wire, which is wrapped around a glass fibre core. When high current spark travels through the coils, a magnetic field is induced. This induced magnetic field helps to cancel the RF energy produced by the ignition current. Spark plug leads normally operate efficiently between 3 and 20,000 ohms per lineal foot of cable length. Check the design specifications to determine if you are testing a copper, carbon impregnated, or a spiral wound core, as the specifications will vary between each. These are normally not individually serviceable and must be replaced as a set. When performing visual inspections of spark plug leads, confirm they are not soaked with contaminants, such as oil or other fluids. These may act as an electrical conductor or prematurely cause deterioration. Leads should never be overlooped or overstretched. Always ensure that they are clipped into the original locators to protect them from rubbing, fraying and heat damage. Confirm the terminal boots are clean and have no evidence of splits, cracks or oil contamination, as any of these will cause tracking on the spark plug or arcing to ground. Never pull a spark plug cable by the lead. Always grip and twist the insulator boot to remove. A faulty plug lead will display engine operating symptoms such as misfire, excess fuel consumption and a loss of power. It's always best to check the secondary ignition waveforms with an oscilloscope. Accurate spark plug diagnosis is crucial when servicing a vehicle efficiently and effectively. So do yourself a favour and brush up on these fundamental principles. Remember, work smarter, not harder. See you next time.